Hello and welcome to my video today. My name is Corey Heisey, and today I'm going to go over some of the textbooks that I've read in software development area that have benefited me or haven't benefited me. I'm going to kind of go through the ones that I've read and gone through and kind of rate them and see how they went, see how they were. So one of the first ones I read was Deep Learning with Python. It's an O'Reilly publication as well. I don't have a hard copy of it because I actually sold it. I sold it a couple of years ago. Just like I read it, make some extra cash, whatever, right? So first let's go through them like quickly here. So I read that one. I had it for a while, kind of read it through, and then I ended up just selling it, which I was able to sell online and through the post. And the next one is this one, Clean Architecture by Robert C. Martin, Uncle Bob. He has a few of them. There's the Clean Code, which I guess is like the original one. But I just did this one, Clean Architecture, and because it kind of encapsulates the clean code sort of tech ideas in it as well. And so I thought it was good. It was easy to read. I think like his dialogue and his reading makes it consumable or readable. And so that's good. And the points are valuable and interesting. I think sometimes he has a bit of controversial ideas or opinions, but I don't know anything about that. And then the next one I would have bought was this one, Embedded Systems. This one's O'Reilly. Making Embedded Systems from O'Reilly, and it's by Elecia White. So I was working as an embedded developer. And I liked embedded software. But this one was a little less valuable for me. First of all, it's more textbooky, like harder to read. But that's okay, you can get through it, it's fine. But it was also a lot more lower level than I really wanted at the time anyways. I didn't finish it. I think I'm like maybe a third way through. I didn't end up reading it from the whole thing. But they had like schematics or how to design your hardware, how to collaborate with hardware engineers, and a lot of things that didn't take value from it. I might go back into it again and because I'm interested in the low level development of like kernel development or kernel, how it works, and how these really low-level embedded systems work. But sort of the hardware, I like it, but I'm not really interested in like the electrical part or So anyways, so it was good, but I didn't finish it. And then the next one that I read, that a buddy of mine, software engineer, who recommended it a while ago. He probably recommended like a year ago even, and then I bought it maybe a few months ago now. From the time of this recording, is O'Reilly Designing the Data Intensive Applications. And it's by Martin Kleppmann. Also O'Reilly. Definitely have good books. But this one's the best one. This one's definitely the best one out there. And there's a wide range of reasons. I think for me, I liked it because it's certainly also readable. It's textbook. It's not a novel, but it's consumable. I can read it. Of course, I have to take a break. And what does it mean? You don't have to think about it. And then the content is, of course, great and very rich. And a lot of things that web developers or any software developers or engineers don't always think about, don't always study about. And the thing that I really liked about it was it had the applications of, or the application of web apps, web development, but to optimize it and then it goes into more of a lower level of data servers and memory usage and load balancing, and how do we actually overcome these challenges of data intensive applications. So it's like interesting in the sense that it's a lot more low level and technical, but also in the real world applications of websites. So Twitter and Netflix and all these big ones, and a lot of the interesting ones points were like load balancing. So on Twitter, if someone has 100 million followers and one of their posts goes viral and everyone's commenting at the same time, you have to be able to handle that peak, as well as not having too much allocation for when it's lower demand. And some of the biggest things is like these atomic actions, atomic requests of, if something happens at the same time, you need to be able to count this one happened and then this one happened and be able to keep track of that, not just it happens all at the same time. And it has examples and diagrams of if something's requested and then another one, and something happens and another one requests the similar thing, it can like kind of get messed up in the timeline that in reality they could see it before it even gets, the other person sees it, for example. And this it talks about like race conditions, and anyway, so it's definitely a goat. It's definitely the goat. And I read it like just from the back, read it, and now I poke at it once in a while to kind of keep up my just because it's interesting. It's a great book. And the next one I've been reading, also a recommendation from my software engineer friend, is this one, DevOps Handbook. And I think there's another one as well. I should say somewhere, but anyways, this is the second edition. So this one's good. And it's, again, I find it readable, it's technical, but it's a little more, has stories and benefits of converting to a modern DevOps from an old legacy system. It also has examples from lean manufacturing or Toyota factory of reducing waste and optimizing these things. So it has a lot more interesting examples and points than just software and DevOps. Some of the interesting examples are the like a hotel or like a company that isn't website, it's a software company, converting to a modern DevOps system and really saving time and money and all those things. Another thing that I found interesting, I'm not done yet, I'm still reading. I got my 3D printed bookmark. But another thing I found interesting is that I hadn't really realized the life before modern DevOps and CI/CD pipeline and automated testing. I hadn't really thought about it. And they said like some of the deployments could be 6 to 12 months. So you start in the developing the update, and okay, finally we can try to deploy it. And now with automated tests to make sure nothing breaks, it can be weekly, daily, multiple times a day that you can implement an update or a patch without too much trouble. And just combining the operational and development departments that traditionally were different or separated. And it's one of those books that, like I already said, it has examples of manufacturing and different things, but you can sort of apply that knowledge to other parts of life, not just in DevOps and software development. So that's really interesting. That's definitely a good, interesting point, or that I take from it. So that's been good. And yeah, those are the textbooks I've been reading and have read or didn't finish for software in general. And going back to the deep learning with Python O'Reilly book, I read it. I first got it maybe in like 2020 and started reading it, doing the examples. It has like code examples for Python. They also have an R version for R language, and they have the theoretical. So they have like TensorFlow coding examples to make convolutional neural networks, creating neural models, and so they have the theoretical explaining it, like what is a neural network anyways, how does it work, and then kind of applies it to, and then helps you create models, it helps create models. And I've done the examples, tutorials, and made models through TensorFlow from their website as well. And they talk a little bit about generative large language models that are now, of course, the large hype of things of ChatGPT and any chats, and of course, right? But it's only one part. I mean, at the time when I was starting into this, I was more interested in the CNN, the convolutional neural networks for computer vision, to be able to recognize an image or train the data on dogs and cats, and then have test it, or you validate it, and train and validate it, and then you test it and say, is this a cat? And then it says, yeah or no. And that's used in autonomous driving. It's used in healthcare for sicknesses and to recognize cancers or different things from imaging. So at the time, I was more interested in that. And the large language models, or even like the generative machine learning, I thought it would be cool to create a model on large language models to write blog posts. So okay, then I could have blog posts that are automatically made, posted weekly, twice a week, whatever, and then have a bunch of content, and then try to monetize that. And writing the whole model yourself would be a little bit. I mean, nowadays you could just use that with, of course, ChatGPT, and of course make your own, using your own OpenAI API to make it even more automated. Instead of having to prompt it and copy and paste and put it back into a blog, you could make your own website, give it like a prompt or idea, and connect it to the OpenAI API. So yeah, and nowadays they have. Everyone's hyped about the LLM. I think people are starting to realize we're in a bubble and a bit of a hype cycle. I'm more bullish on the world models for further progress, because I think the LLMs are kind of capped. Just kind of like, add another layer, it improves, but the language is kind of limited. But I'm kind of excited about other ones, like the computer vision, the convolutional neural networks, not just worldview or world model, which incorporates all these sort of things, but sort of these more specific things, or more use cases, more edge cases, more like the embedded machine learning of monitoring a system and having a device that can have inference and learn from it and optimize, like a machine, like in a factory monitoring a machine or something, for example. But yeah, so that's my cap of some textbooks. And again, best one is this one. Recommend it, buy it, read it, and yeah, that's my story. So thanks for watching. Until next time, bye for now.